Hello, welcome back. We're going to continue talking about Chapter 7 today, subproblems. Let's take a look at an example problem. The capacity of an elevator is either 20 children or 15 adults. If 12 children are currently on the elevator, how many adults can still get on? You might remember we've done this problem before, but we used a different strategy. Today we're going to do this problem again, but try to use subproblems. Let's start by talking about what you might do first. And one of the things about this problem is there's a lot of approaches you might take to this problem. There's a lot of things you might do, and you might want to do, you might think, okay, I'm going to do 20 divided by 15, which that's the same as 4 divided by 3 or 1.3 repeating. Or maybe you have a strategy that might involve doing this first to get 0.75. Or you might do the capacity of 20 minus 12 to get 8. That might be your first step. Or maybe you're going to do 12 out of 20 as your first step to get 0.6. Or what else might you do first? I don't know. How about 1 out of 20 to get 0.05? Or, well, you can see there's a lot of different things you might do. And there are a lot of different approaches you can take for this problem. But the key for this strategy is whatever step you're going to do first, as soon as you write a step like this, you should stop, rewind, and think about what you actually just found. And what you should do is you should actually write a question before you do that step. So for example, if I'm going to do 15 divided by 20, which is simplified to 3 over 4, what I'm actually doing is I'm answering the question, how many adults can get on for every one child? Okay. Or if I'm doing 1 out of 20, I'm asking the question, what percent of the elevator does a child take up? And that would be 5%. How many children in one adult worth? Was this a question a student wrote last year? And that's 4 divided by 3 or 1.3 repeating. Some students decided to use ratios. So the question would be, what's the ratio of children to adults? If you're doing the 20 minus 12, that's the question, how many more kids could get on, not one, on the elevator? And there's room for 8 more kids. If you're doing 12 out of 20, the question you're answering is, what is the percentage of the elevator that is full of kids? And that's 60%. Now, these are all things that could be a first step to this problem, depending on what you're going to do. What I would like you to do, though, is I would like you to pause this video, and I would like you to, whatever makes the most sense to you. Maybe you're going to use one of these as your first step. Maybe you're going to do something different. But I'd like you to finish this problem using subproblems. And then when you're ready to check your answer, you can go ahead and press play. So go ahead and do that now. Hi, welcome back. Did you actually press pause? Did you do this problem? Did you? Are you lying? You did, didn't you? You did the problem? Oh, good for you. I'm so proud of you. Well, here's the way I did it, which might be different than the way you did it. I did this as my first question. What is the percentage of the percentage of the elevator that is full of kids? And that's 60%. Then I said, what percent of the elevator then is empty? And that's 40%. And then I said, how many more adults can get on the elevator? And another way, what I'm actually doing then is what's 40% of 15. And notice, this is not the way I'd write the question. That really doesn't have any context of what these numbers are actually talking about. This is the question I'm answering by calculating what's 40% of 15. And 0.4 times 15 is 6 adults, and that's my final answer. Again, you can see I used 3 questions to get there. There are many other strategies you could use to get here, but starting with any, one of these could work. But in the end, you should get 6 adults. So your homework for tomorrow, page 212, number 1, you'll notice that is from the portion that is the practice test, which means for this problem you can use any one of the previous strategies. So if you look back to anything from chapters 1 through 7, you can use any one of those strategies to try that problem.